All right, we're here for the first episode of Make Cool Shit TV. We're at Made in America Manufacturing, where they are a machine shop. So we're about to see some stuff where they're machining some hard metal. Their claim to fame is titanium tight tolerancing. So we're gonna give you a look inside at how this stuff is made, and hopefully you can learn something. I spent 15 years in the manufacturing world, and now I'm on a mission to show people how things are made and excite the youthful generations to get them involved in this amazing industry. This is Make Cool Shit TV.
I've been in the manufacturing industry my whole life, since I was about 18, 19 years old. And while I was working at another shop, I made the decision to buy a machine, add three-phase power to my house so I could start making parts at home. So it started off in the garage of my house and built from there. We had one person working day shift, one person working night shift on one machine in the garage of my house. The neighbors would stop by all the time and ask me what was going on. And then it slowly built up from there. From that point, I actually moved the shop into my buddy's shop. You know, we kind of worked together for a little while, and then we moved into this facility in 2017. So this is kind of where the process starts. Once we receive an order in, you know, and the material comes in, we receive it in. It all gets labeled. Believe it or not, the traceability is ridiculous. Once your part makes it to its end user, if there were ever an issue, they need to know who made it, who inspected it, where the material came from, all the way down to the mill. So we bring it into here, and then normally we bring it to the big hem saw, and at that point we cut it up and get it ready for the machine and take it down there. And it could start on the lathe, or it could start on the mill, depending on the geometry of the part. So we cut it down from size here into the smaller pieces just to get it ready to go on the machine. Like I said, we cut the hardest material you'll ever see. So everything on that bottom is titanium. There's a piece of stainless, and this piece of material right here is Inconel, and Inconel is what they call HRSA. It's a heat-resistant superalloy. This is probably one of the most, if not the most difficult to machine metals there are. So this material is very, very tough, and it pushes the heat back into the tool. That's why they use Inconel for downhole applications, because they can put it downhole on a drilling rig, and it can handle the heat and, you know, that environment down there, and it won't collapse.
Caused by it. Rotating the friction.
Yeah, we're making a part right now that mounts directly to the drilling head to go down there and send sensors back up top. What we do here, we're what you call a job shop, a contract manufacturer. Basically what that means is we'll make anything. Tight tolerance, complex components. This company makes parts that probably 95% of other manufacturers will not make. Either the risk factor is too high, the skill level isn't there, the machine capability isn't there, the inspection capability isn't there. It could be a multitude of reasons, but our tolerances that we hold is what we really hold to high esteem. Yeah, so you can see once it comes off the saw, we'll haul it down here, and it could be anywhere from this big material to square block to small round stock. And then we come in, and depending on the geometry of the part, it depends on what machine it goes to first. So the square material is obviously going to go to the mill first. The round material normally starts on the lathe. Each one of these pieces is probably about 30 pounds, 35 pounds. This entire piece of material when it started weighed 1,700 pounds. Depending on the size of the part, if it's a smaller part like the ones I showed earlier over there, it'll come over to this lathe. This is a smaller lathe. It's got a smaller work envelope. So the machine's not moving as far, so you can move more efficiently. So a lathe is there's different variations of a lathe, but this is a 2-axis slant bed lathe. So the biggest difference on a lathe and a mill, on a lathe, the material turns. Right. On a lathe, you hold onto your piece of metal, and the material turns, and your tool is static. Okay. Your tool doesn't move. The difference when you come over to a mill, the material is static, your tool moves.
Got it.
And the majority of the time, if not all the time, the lathe is handling a round part, a turned part, a gear shift knob,
you know, like screws and nuts.
Screws, barrels, nuts,
round shaft,
gun barrel, things like that. versus your square parts, you're going to see from the little retainers that we had down there and some other parts that we'll see over here. Versus, you can see the mill, the table itself moves versus the turret. You can see in this machine that the material is static. The material stays held in place, and the tools are going to come down and move around. That's the biggest difference. We've got the larger lathes for the bigger material, and these are the bigger machines where we can handle anything up to a 16-inch diameter part to 30 inches long, which we normally don't do parts of that size, but if we do, then we use a forklift to get them in here and drop them into place. So these are the little bit bigger machines, and then you can see over here where the mill work is at. This is very different from the lathe parts. So just for visual, this is what you would see as a lathe part. It's round, it gets turned, and this is what you would see as a mill part. Obviously, it's not going to be able to spin and be cut.
Right.
Versus these mills, and then this is a four-axis mill, so you've got your X-axis, your Y, your Z, and your A is your rotary. And this machine is a 5-axis machine. The rotary's pulled off of there right now. So that's the biggest difference here. And then the two machines that are in the quality department, those are CMMs. They're only for inspecting the parts. They don't cut anything.
What's with all the fluid and what's that basically used for?
So that's for coolant, because when it comes to machining, heat is your enemy. So you think about any piece of metal that you've ever dealt with, when you get it hot, what does it do? It melts, it gets soft, so we don't want that. So basically in the machining process, we're taking a harder piece of metal and cutting a softer piece of metal with it. We're using carbide tooling to cut metal that's a little softer than that on the hardness scale. So you can see on the two parts, it'll start out with this blank with no holes or features in it, and then once we run it through this operation, we will drill all these holes and we'll thread mill and put all the threads inside of it.
Take to go from that stock to the hold. I mean, how fast is this thing?
So this program right here is an hour-long program. This part as a whole takes 6 different operations. So it takes 2 different operations on the lathe, and then we take it over to the mill and we do a 90-degree rotary operation to get the radial features, and then we bring it over here and do a 10-degree operation to put the holes at an angle. Then it goes back to the lathe to drill out the other side of it, because we have to have the material that's solid or the drills will walk. You know, so that's where I was talking about your approach on a part, learning your approach. And then we bring it back to the mill, and there's one more feature on the bottom of it. So this part moves around quite a bit.
Software to then figure out the machining cuts, or how does that process work?
So we do use a CAD/CAM system that'll program the machines, but your approach on the part, that comes from your experience. So you could take this same part and you could take it to a shop down the road and they may make it slightly different. So that's the competitive side of this business, where you can take a part that somebody else may have been making previously and figure out a better way to make it. You know, so it's really exciting where you can take this part and you can say, all right, I think I'm going to combine these 2 different ops with a more high-tech fixture, or the fixture that's a modular fixture or something like that. So it just depends on the part, but that's normally done. The CAM system doesn't dictate how you're going to machine it. It just helps you produce the code that the machine reads. I tell everybody, you think about the machine as a giant piece of graph paper, and you're going to set wherever that origin is at. On these machines, they call it a work offset. And then from there, just X coordinates, Y coordinates, Z coordinates. Just as the machine adds more axes, you just need to be working in those dimensions. So as you add a rotary, there's another angular rotary that you're going to be spinning around. As you add a 5th axis, you know, you're just moving inside of that graph paper, so to speak. And you're going to take the geometry of the part and move the tools into the position to cut out that material. Yeah, so the first step would be, is as it comes in the quoting phase, I'm going to figure out how we're going to make it in the very beginning. You know, I think we're going to make it like this. This is going to be our process, and then when we bring it in, I'll sit down, I'll program it on the CAM software. It has a 3D simulation that we'll use, you know, to verify that it's going to work, and then we'll bring it out here, and the guys will load the tools that we've decided we're going to use to cut it. And then this machine actually has a probing system that actually touches them all off, figures out where it's at, and then we build our fixtures, set it up, indicate our part in, get everything perfectly true, and then we'll run through our program and prove it out. And after our program is proven, then we save that program for the next time we get the order. What's interesting is you'll find in this industry is, so predominantly you've got two machines that are gonna be your workhorses, a mill and a lathe. There's other pieces of equipment, there's EDMs, there's water jets, there's lasers, there's things like that. But 90% of what you'll see is a mill and a lathe. And throughout the industry, you'll see a lot of guys, they're either a mill guy or a lathe guy.
Yeah.
So when you talk to them, this guy will say, well, I've been on a lathe for the past 15 years, I run a lathe, that's what I know. Because the tooling over here is different, the work holding is different, how you go about machining, the programming is a little bit different. Versus you'll meet a guy that says, I'm a mill guy, that's all I do. He's used to putting vices on there and building fixtures and loading tools and doing a completely different type of part. Because they're very different from round work to square stock. Yeah. It's a completely different process to get to a finished part here and to get to a finished part here. And what's funny is with someone's skill set, you can see either this clicks with them, either they come over here and this has 2 axis on here and they completely understand it, or they come over to the mills and it could have 3, 4, or 5 axis and they get it. So a lot of times you have to figure out the person's skill set to what they're strong at for the different types of machines. Yep. Because the geometry that you're cutting and how you're going about doing it is very different. You could take a guy off on this machine and go to put him over there and he'll look at you and be like, man, this is completely new to me. It's just it's a different world. Right. And it's a different set of problems that you have to overcome machining over here versus over there. On the mill, when you put the part in there, we can actually program it and a probe will come down and find where that part is at. We'll tell it where it's at the first time and after that, so that gives us really good repeatability, really good accuracy, and really good tolerance to where we'll know this probe will come down every single time, find that part and make sure we're dead center on it. So the more automated that we can get in some of these processes, the better off we are on our quality. And these parts you'll see, they go, obviously they were a round part, so we started them off on the lathe, and then you'll see all the small holes inside of them that we bring them over here to the mill and do that on. Yeah. So once we bring the parts in, once they go from the saw to the lathe over to the mill, and we have a finished part or an in-process part, we'll take it into the QA room and we'll run it through the CMM. And on that part, the CMM will actually save all of our results for the PO number and the line number on the PO, and we always keep that data for about 7 years. So if anything were to ever come up, we can pull it back up and say, here's the information that we got. But these guys right now, they'll pull them off the machine, set them on the Zeiss, hit the start button, and then it'll do a full inspection on the part for us.
Yeah, let's go check that out.
So you can see this would be one of the parts that he's running out there on the mill right now. So after we finish all of these features, we can bring it in here and load it onto the CMM. And this machine actually takes these calibrated stylus and it's going to come in here and inspect each one of these features and give us a printout of exactly the dimensions of the part, so we can compare that to what the blueprint says and make sure that we're in tolerance and we're meeting the specs of the customer.
So, and not all machine shops have equipment that's as high tech as this. But why did you guys invest into it? Because
we do, like I said, we do very complex, very, very tight tolerance parts, and we needed a machine that could meet those standards. So you're right, not all manufacturing facilities have a piece of equipment like this. It's because they don't all do the work like this. So we take on a different level of work. So we have to have the equipment to back that up. So basically our customers, a lot of times, they basically ask for absolute perfection. The product that they're making, the fiber optics, they have to be perfect. So you think about if you're making a product that goes, 1,000, 2,000, feet to the bottom of the ocean, and they go to connect that, and the fiber optics don't make contact, it's going to be very expensive. Yeah. So they have to have that perfection to make sure they don't have a failure at the bottom of the ocean.
Because then they have to bring it back up.
Exactly. Yeah. So this guy will sit here and run, all day, sometimes all night, and create the reports for the parts. Once the parts have been inspected, verified, and they get signed off by the quality manager, at that point, then they go and get cleaned. They go through an ultrasonic tank, get cleaned, they get packaged, and then they go to the customer. And I would say the biggest struggle, besides finding good customers, is building a strong team. Finding good employees that are skilled employees, because in this industry, no one's getting into it. There's no young people that are learning it. They're not going to school for it. They're not pushing it hard enough in the schools. If you go out to, say, more of the rural areas, they have like a VICA club where these guys are building go-karts and working on lawnmowers and cars and things like that. Versus you come into the bigger cities, they don't have that. They're pushing a computer science program or something like that. Well, there's nothing wrong with it, but this has become a dying trade. You know, so the people that are getting into it, we have to personally go out and recruit them and try to grab them. And what's crazy is when you do talk to them and tell them what you're doing, they didn't even know this existed. You know, and I feel like this is the backbone of the country. You know, we make everything. Everything that you see on a day-to-day basis, the calculator, the pen, your glass at the restaurant has gone through a machine shop. They've made the mold, they've cut this, some portion of it, and I don't feel like they're pushing it enough. So I think that's probably one of the biggest struggles. And the training is, once you get them in here, you want to spend a lot of time training and teaching and building them up. And I really wish people would take that into consideration into the school programs, trade programs and stuff like that, and put a little bit more emphasis on it.
My name is Lang Vo. I guess my official position now would be lead of the CNC department. Originally, my dad worked at a company called Tico in Ohio, and they make like all the vise holding systems for machining. And right before I graduated high school, he asked me if I wanted to work there, and so I started in shipping and receiving. And before that, I was like working at Taco Bell for a couple years, and like when I was a kid.
My name is Anthony Smalley. I'm a shipping and receiving manager, as well as I'm a machinist. My buddy had told me about Braden, and I've known him for a while. And I came up here to go and just see if it'd be something I'd be interested in. And because I had absolutely no idea anything about CNC at all. And after being here for a little bit, looking around, I just kind of asked for a spot, and he let me give it a shot.
My wife happened to find Braden on like Craigslist, and I just happened to come in for an interview. And I had another job lined up, and I was gonna take it, but I met him, and I was just like, he's got like the spark.
Pretty much sweeping floors, paying bills, just odd jobs around the shop. I've learned just complete night and day. I know so much more now.
I don't know, there's a lot of satisfaction with working, with your brain and your hands and making stuff that no one else can make. I think the one thing I could say is anytime you're out and about and you look at everything that you see, buildings, cars, planes, that's all this type of work, and they're running out of people like that to do that work. That's why it keeps going overseas now.
How you could just take metal and just have instant gratification, because it's whatever you think of, you can make. And it's right then and there in front of you.
I think if I could talk to young people to give them inspiration to get into this industry, is that the sky is the limit. And I don't say that as something cliche. This industry, you have the opportunity to go as far as you want with as hard as you will work. I started at nothing. No college degree, no background, no training, absolutely nothing. You just have to have the drive and the work ethic. And you can get into this, and the opportunities are endless. You don't have to spend $80,000 at some fancy college. You can get into this and put in the work. You can learn the code, you can learn the math, you can learn the trig, you can learn the machines, you can understand the metal, and you give yourself 6, 7, 8 years in this industry, or even less depending on your drive, you could be working in manufacturing, helping NASA. You could be working on a SpaceX project. You can do great things in this industry if more people found out about it and they just sink their teeth into it and work.
And the one thing I've learned about this industry is that like a lot of kids go to college and they want to take engineering courses, but they don't really know how to make anything. So they're like learning CAD, they're learning, software basics. Then they think when they get out of college, they're going to be a $100,000 a year engineer with no work experience. But people like Braden and I, we kind of like started on the inside and worked our way up into engineering. So you like learned how to make a part flat.
Because like a lot of people, they don't know about this industry. They don't know what you can make and what you can do. And I was one of those people that was hands-on, like to work with things, and I kind of fell into this. Once it took off, it was just really exciting for me, to be able to come home and make something, to have an idea and turn it into something.
With this skill set, anything is possible. You can make anything, even your wildest dreams you can make with just this, whether you buy it or you make it yourself. This career will help you out a lot. Keep on trying. If you don't fail, you'll never try anything in life. So don't be scared to fail. I feel like this is going to be my career. This is where, to the end of the line for me.
All right, so we just finished up at Made in America Manufacturing for the first episode of the vlog. We were here in South Austin, Texas. talked about machining titanium, doing some stuff for the military, the government, underwater stuff for oil and the gas industry. I mean, there's some cool stuff we saw. Hopefully you guys learned some things about machining, get you excited. One of the guys had no experience whatsoever coming into this industry, started sweeping floors. A year and a half later, now he's on the machines, working the machines. You guys saw that, and hopefully that gives you some inspiration to get into this industry. So that wraps it up for the first episode, and we'll see you on the next one.